In example 7, we have a mix of type 1 and type 2. So our type 1 linear factor we just have as x. Okay, it could be x minus 1, but in this case it's just x, our linear factor. And we have our type 2, which is our squared factor, x plus 2 all squared. So to set this up, we need to set up our linear factor. Okay, so a over x, and then we also need to set up the type 2 factor. So type 2 is going to have our squared factor, just one of them, and our squared factor squared. Okay, so once we've set this up, we now need to set up a system of equations to solve for a, b, and c. So to do that, I'm going to just get a common denominator. So I'm going to multiply, my common denominator is going to be x plus 2 squared. So on the a, I need an x plus 2 squared in both the numerator and denominator. And that's going to generate an a times x plus 2 squared part, plus, for the b, I'm missing a factor of x plus 2, so I need an x plus 2 here. And I'm also missing a factor of x. That now makes it a common denominator, so I need both of those there. So I'm going to end up with b, and that's going to be times x and times x plus 2. Plus, for the c factor, I'm just missing a times by x, so I'm just going to times by x, and that's just going to give me cx. And by doing that, I know that's going to be equal to the original numerator, 5x plus 4. Okay, so we can set up a system of equations to solve this. We can generate zeros by substituting in x. I'm going to mix some methods. So I'm going to do this by solving for a by substituting x equals 0. And here that will generate a 0 factor here and a 0 factor here, which means then that those will disappear. So when we do that, I'm going to end up with a times 0 plus 2 squared, and that's going to give me 4, plus, well, because the b has a 0 factor, that's just going to end up being 0. The c has a 0 factor as well, so that's just going to end up being 0 as well. And then that's going to be equal to, when I substitute in 0 for x in this portion here, right in there, I'm just going to be left with 4. So I get 4a equals 4, and that gives me a equals 1. So that, creating 0 factors, solves for one of my variables a. So then I'm going to use this, but now instead of creating 0 factors, I'm just going to mix my strategies here. So we have a variety of strategies. I'm just going to set up a system of equations. And to do that, I'm just going to expand out these brackets. So this is part 1. Part 2, I'm going to use this different strategy. Again, I could use the same strategy, but I'm going to mix it up a bit. So here I'm going to expand out the brackets. X plus 2 squared is x squared plus 4x plus 4, plus, this becomes bx squared plus b times x times 2, which is 2bx. Okay, make sure that's clear. That's 2b. And then plus cx. And that's going to be equal to 5x plus 4. Okay, so we know that a is equal to 1, so I'm just going to replace that with 1. So replacing that with 1. So instead of a, I'm going to put 1 in here. So then I can group my terms. So I'm going to group my terms here as I have 1 plus b x squared, and that's going to match my x squared coefficient. Okay, so I can solve for b. In this case, it looks like b is equal to 1. Well, sorry, that's not equal to x squared. That's going to be equal to 0. So just make sure that that's not the same. So that's going to be my x squared coefficient. There's no x squared coefficient on the right-hand side. So 1 plus b is 0. So b looks to be negative 1. And then I have plus, my x terms are going to be 4 plus 2b plus c. Okay, so 4 plus 2b plus c, that's going to be the coefficient on x. So that's going to be equal to 5. All that's going to be equal to 5. And then, so I'm going to just make sure I match those all up. And then I also get 4, this 4 equals a plus 4 here. I've matched up those coefficients. So plus 4, and that's equal to 5x plus 4. Okay, so just keep it color-coded so you can see where all the terms that match up. So that plus 4 already matches up. I have to solve for b and c. Now, I want you to notice that there's a 0x squared coefficient, so we know that it's going to be 1 plus b is going to be equal to 0 because there's no x squared coefficients on this side. That then allows me to solve for b. b is equal to negative 1. So now at this point I have b and c. So a and b, and then I'm going to solve for the c value by substituting into the middle coefficient. So I get 4 plus 2b plus c is equal to 5. I can replace that b with a negative 1. So negative 1. And then solving for c, c is equal to 4 plus negative 2 is 2. So subtract 2 from both sides. I get c is equal to 3. So now I've solved for a, b, c. I can then set up my integrals to solve this. So my integrals are going to look like this. So starting with the a, I end up with the integral of 1 over x dx plus, going over to my b, I'm going to end up with negative 1 over x plus 2. Okay, so those are both going to be log integrals. And then for c, I'm solving for c, it's been plus 3, so it's going to be 3 over x plus 2 all squared dx, and that's going to use a power rule integral. So working this out, this becomes log x plus, I was going to say minus log of x plus 2. Those are both power 1, so they involve our log integral, plus, in this case, we're going to use power rule, so it's going to be power negative 2 goes to power negative 1 and divide by negative 1, so I'm going to end up with negative 3. The negative 1 power just becomes x plus 2, and then we have to remember that there's a plus c. We can combine those a little bit. The logs can go together. X over, negative log means divide, so x over x plus 2 minus 3 over x plus 2 plus c, and that represents the integral of that. So what we did is we split it up into type 1 and type 2. We solved for the a, b, c coefficients, put them in the integral form. Once they're in the integral form, we have our log forms with x and x plus 2 in the denominator. X plus 2 squared, remember that that is not a log, that is a power rule, and we generate this integral when we do that.